Hi, I'm Dustin.
I'm Trevor.
And today our scientific video is dedicated to Newton's third law of motion.
I'm Kyle and welcome to our video. Formally stated, Newton's third law is, for every action there is an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the forces on the second object.
Our first example of explaining Newton's third law is by using a rocket.
No, you don't.
Don't worry about it.
Okay. I just don't
Oh,
want
the
to.
light came on. Look at that.
I just
Ready?
don't. I don't want to be.
Oh my! Where'd it go?
If I was standing there, I would. Yeah.
To space! That's in the trees.
Well, start walking. Why don't you leave the igniter?
Where is it?
Where'd it go?
It's past the tree. Can't you see it? It's coming down. It's approaching the top of the trees. Can you see it?
I see nothing.
It's Kyle.
Oh, I see it. Oh, that's way the hell away. So as you saw in our first launch, there are several forces that act on a rocket in flight. You have the force of the fuel burning, which is what propels the rocket forwards, force of air resistance, which pushes back the rocket, as well as the force of gravity, which acts pretty much the same as air resistance as long as the rocket's facing straight up. So, with the fuel burning, the opposite reaction from Newton's every action has an equal and opposite reaction will be the force of the burning gas, which will be coming out of here. This is what acts as this force here, propelling the rocket forwards. So taking all these into account, since rockets obviously go upwards, as we showed during that launch, the net force is up, very up, to space up. So, the force, so this is the gas coming out of the bottom of the rocket. So here we have the force of the burn, which is the expanding gases propelling out the bottom. And then up here we have the surrounding air, which is slow. We'll be slowing down this air. I should say the surrounding air is stable and not moving very quickly compared to the air coming out of the rocket. And so as we can see from the launch, all the gases come out the bottom, so the net force for the gas is down. This is the force. This is the equal and opposite force to the force of fuel on the rocket, shown here. These two are the equal and opposite reaction.
Our second and final example of explaining Newton's third law is a ball when kicked.
Okay, ready? To space!
As you saw when we kicked the ball, there are several forces coming into play. Obviously, you have gravity and the normal force keeping the ball on the ground. Then when your foot makes contact with the ball is propelled forward in an action-reaction pair. The foot pushes the ball forward, and in turn the ball pushes the foot backward. The only thing slowing down the ball after it is kicked is friction, which is FF, and the net force is forward.
In this free body diagram, we show the foot that kicked the previously mentioned ball. The forces acting on the foot are the force of gravity pulling down on the foot, Fg. We show the force of the leg holding up the foot, F leg up. The force of the muscles pulling the leg and foot forward, F leg, and the force of the ball pushing back on the foot, F ball. As you saw in the example, The foot carried on forward after it kicked the ball, so the force of the muscles is greater than the force of the ball pushing back on the foot. Since the foot carries kinetic energy with it as it moves, when it contacts the ball, energy is transferred from the foot into the ball. This pushes the ball forwards and the foot backwards. The F net force is in the same direction as the foot when it makes contact with the ball, because again, the force of the foot carries much greater force than that of the ball. And there you go. That is Newton's third law explained in a nutshell. Thanks for watching, and we hope you enjoyed it.
This is the importance of fins.
Yeah. This is the importance of fins, and this is why teenagers are stupid. There's the light. It's gonna blow up. Wait. There it is. So, light of doom.
Yep.
Warning us of our impending stupidity. Here we go. That's
What was that?
Right. There you go. And that's called science, kids.
Okay, your what?
This is the free. Oh my gosh.
Oh my god.